It's a hello from West Virginia. And then again, it isn't. Oh well, but what is joke of the day? Because I know you love joke of the day. It is, without a doubt, the best part of the day. So, how do you think the unthinkable with an iceberg? That's a play on the Titanic, where it hit an iceberg and they called it the unsinkable ship. So, how do you think the unthinkable with an iceberg? Okay, well anyways, what we've got here is the point-slope form of the equation of a line. So this is one of the many forms of the equation of a line. We do have our slope intercept form of the equation of the line, and we have our standard form and general form of the equation of the line. And I'm going to show you where the point-slope form comes from. What we have is the formula for slope. You are familiar with the formula for slope that says I'm going to subtract my y's on the numerator, I'm going to subtract my x's on the denominator, and as I've said before, doesn't matter the order you subtract those y's, just as long as you go in the same order in the x's. So I could have put y1 minus y2, and if I did that I would have put x1 minus x2. It doesn't matter just as long as I've got them in the same order. Now, I'm going to do a little bit of rearranging with this formula, and the first thing that I'm going to do is the fact that I have a fraction here, I'm going to get rid of the fraction. And you guys know how to get rid of fractions now, because remember, what is making this a fraction is that denominator. So if I want to get rid of the denominator, what do? Yes, I undo this division that's sitting here, and the way that I undo division is I'm going to multiply. So what I'm going to do then is I'm going to multiply both sides by that denominator of x2 minus x1. And remember, this whole idea of pan balance means that if I'm going to multiply this side by x2 minus x1, I've got to multiply this side by the same thing as well, keeping it all balanced as a pan balance. So these will cancel out completely, and what I'm left with is an x2 minus x1 times m equals y2 minus y1. Now the next thing I'm going to do is I'm going to say, well, you know what? Multiplication is commutative and associative. And we know that that means that if I take a 2 times a 3, I'm going to get the same thing as if I do a 3 times a 2. I'm going to get the very same thing either way. So because of that, this is parentheses times m. So I can do it that way, or I can flip it around and I can do m times parentheses. That's legal, right? Yeah, it is, because multiplication is commutative, and the commutative property says you can switch the order of what you're multiplying. Now, I'm being very careful here. It's parentheses times m. So when I switch it around, it's going to be m times parentheses. Now, the other thing that I'm going to do is I'm going to say, remember that idea of pan balance? And we said that when we have that pan balance, right here, the fulcrum in the middle is the equal sign that's in this equation. When you have a pan balance, can you flip your pan around like this? Yeah, you sure can. Now, it might teeter a little bit. It might, do this. But I can spin it back around, and it'll teeter a little bit, but it'll level out. So the idea here is that fulcrum in the middle, I can just spin and spin and spin around that pan balance. It'll teeter, but it'll always level out because it is a balancing act with a pan balance. So what I'm going to do then is this fulcrum in the middle, I'm going to take this side and flip it over here, I'm going to take this side and flip it over here. I mean, it's a pan balance, so it's perfectly legal to do that. So this side's going to slide over here as y2 minus y1 equals m times x2 minus x1. And the last thing that I'm going to do is this idea. Remember, I said that, well, I didn't say it, but I'm about to say it. This is not an exponent. It doesn't mean y to the second power. This does not mean y to the first power. This does not mean x to the second power. And this does not mean x to the first power. These are subscripts. And what they actually do is they say this x and this y go together as the second point. This x and this y go together as the second point. It's just kind of a grouping sort of thing. So if that's the case and it's a grouping sort of thing, then what I'm going to do here is I'm going to take the subscript off of this one and this one because they still go together. Subscripts on these and these mean this is the first x and the first y that go together with the first point. This x and this y go together because neither one of them have subscripts. And my friends, this is the point-slope form of the equation of a line. It is basically just your formula for slope rearranged. That's all it is. Now, when you have the point slope form of the equation of a line, you can either pull information out or you can plug information in. And one of the things that you can plug in is that slope. Now, you know slope is always the m. The other thing that you can plug in or pull out is a point that's on that line. Now, we have to be careful here. The reason that I pulled the subscript off of this one and this one is to let me know this one here and this one here, the ones that actually have a number subscript, those are going to be numbers. So the subscript is not on this one, it's not on this one to remind me those are going to be variables. So if I'm given a point, let's call it x1, y1, then I can take this information, I can plug this x coordinate right here, I can take this y coordinate, plug it here, and I can take my slope and plug it in there, and then I can write the equation of a line. So this is a beautiful form to use, wonderful form, when you are given a slope and a point. And guys, mathematicians are not creative. We call it like we see it. So if it's called the point slope form of the equation of a line, then that means if you're given a point and a slope, plug it into the point slope form of the equation of a line. We're not creative, and that makes life easy. Or I can use this form when I'm given 2 points. And you may be saying, no, wait a minute, I have to have a slope, remember? Point slope? I got to plug something in here. But folks, if you are given 2 points, can you get the slope? Oh yeah, you can, because you've got your formula for slope right here. So if you're given 2 points, you can plug those into this formula for slope. You can subtract your y's on the numerator, you can subtract your x's on the denominator. You can come up with that slope, and then the beauty is you have 2 points to choose from in terms of plugging in here. Now, it doesn't matter which of those 2 points you choose, and I'm going to prove that in a later example. But first, let's take a look at a couple of examples that I've got for you. Now, we're going to run through several examples in this section because this is something that people struggle with, and you know I like to give you several examples so you feel very comfortable with it. But in each and every one of these examples, what we're going to do is we're going to write the equation of the line given the specified conditions, and then once we've written the equation, we're going to transform it into slope intercept form, and then after we've translated into slope intercept form, we're going to translate it into standard form. But first we have to write the equation of the line. So take a look at, we've got this condition. We are given a slope of 1/2, and we are told the line that we're writing the equation for, that line passes through this point, -4, 3, and has this slope. Now, like I said before, mathematicians are not creative people, folks. If you are given a point and a slope, what do you think you're going to plug it into? Yeah, point slope form. So what I'm going to do is I'm going to write down that point slope form, because you know what? If you've got something that you need to memorize, the easiest way to memorize it is to write it down every single time you use it. You will memorize it without even trying. If you write this thing down 10 times, I'm telling you, you're going to memorize it. I never had to make flashcards. I never had to stare at a paper and study it. I just wrote my formulas down every time I used it. And I'm telling you, you're going to memorize it without even trying. So it's written down. And remember, I took the subscript off of this one to remind me it stays as a variable, and I took the subscript off of this one to remind me it stays as a variable. Now I'm going to plug my information in. I'm told the slope is 1/2. That goes right here where that m is. I'm told that the point is -4, 3. So what's going to go right here? Yes, that's going to be the y coordinate of the point, and then this is going to be the x coordinate of the point. So I've written the equation of the line. Now with point slope, there's this thing that I call cleanup. Cleanup is easy to do because you know subtracting a negative is really adding a positive. So I'm going to clean that up because subtracting a negative is a bit cumbersome. So I'm just going to clean it up as, whoops, not x plus 2. I don't know what I was thinking. X plus 4. So I have y minus 3 equals 1/2 times x plus 4. What I'm not going to do is I'm not going to distribute that 1/2 through. Because remember, my point slope form looked like this and had a parentheses in it. It had y minus, and then it had slope times with a parentheses. So I'm not going to distribute through and try to get rid of that parentheses. As far as writing the equation of the line goes, I'm done. This is point slope. But remember, the directions had 3 parts. Part 1 said, write the equation. Done, did it. Second part said, now let's translate that into slope-intercept form. So we need to remember what slope-intercept looks like. What is that? Yes, that's y equals mx plus b. So I need to translate this, and I'm just going to write it sideways like this. Y equals mx plus b. I know that's kind of bad. But how do I know that this now looks like that? One thing is there's no parentheses in this y equals mx plus b. It's not there. And the other thing is that there's no parentheses there. So I've got 2 things I have to do to make this look like this. And like I said, one thing is I need to distribute this 1/2 through the parentheses to get rid of it. The other thing is let's slide this -3 to the other side so that the y will be by itself. Now guys, it doesn't matter the order you do that. Just get both things done. So you can slide that -3 over and then distribute the 1/2 through, or you could distribute the 1/2 through and slide the 3 over. I tend to go ahead and distribute first and then slide that 3 over, because a lot of people make mistakes doing this. They'll slide that 3 over, and then when they distribute through, they actually do get kind of excited about distributing, and they go distribute, and they distribute all the way back here to the 3. That's a common mistake that I see. So to prevent that mistake, I'm going to distribute first and then slide the 3 over. So like I said, in the distributing, I'm going to get a y minus 3 equals 1/2 x plus 2. I'm very close to this slope-intercept form. I just need to add that 3 to the other side to get that y by itself. And when I do, that'll give me y equals 1/2 x plus 5. Ta-da! We are in slope-intercept form. Now, remember, there was a third part of our directions that said put it in standard form. We need to recall what standard form looks like. That was my ax plus by equals c. And remember, with standard form, there were 3 criteria that needed to be met. One criteria is we need to make sure we have no fractions and decimals, so I'm going to need to get rid of that 1/2. The other criteria is to get the x and the y together on one side of the equal sign and the constant on the other side. So this needs to get over here with the y. And the last one is to make sure that the x coefficient is positive. 3 things. Does not matter the order you do them. Just get all 3 things done. So I could slide this over first, and I could change its sign to make sure that it's positive, and then I could get rid of the fractions, or I could do the fractions first. It doesn't matter. Just get all 3 things done. Most people like to get rid of the fractions first. So I'm going to do that first. What is making this a fraction? Yes, it's that denominator of 2. So I'm going to take the whole thing and multiply by that denominator to get rid of it. So that will give me a 2y. And here we know that when we multiply those fractions, you are still in my math, gang. So we are going to cancel in those diagonals when we multiply fractions. These 2's are going to cancel out, and I'm left with an x. And then 2 times 5 will give me 10. Ta-da! Fractions gone. It's a beautiful thing. So one of the 3 criteria is done. Got to take care of the other 2. Now I'm going to put the x and the y together. And in order to do that, I'm going to subtract that x off, giving me negative x plus 2y. Remember, this is positive, equals 10. Second criteria done. My x and my y are together on one side. The constants on the other side. And remember, that third criteria is make sure this is positive. So I'm going to take the whole thing and I'm going to multiply it by a -1. Or I'm going to divide everything by a -1, but you know what that means. I'm just going to change all the signs. So this becomes x minus 2y equal to -10. Ta-da! It's a beautiful thing. We are now in standard form. Standard form. So we have our point slope, we have our slope intercept, we have our standard form. Now, let's try a few more, because this is something that people really do struggle with a lot. I want lots of examples so you feel comfortable with this. So I've got the same directions. I need to write the equation on the line, I need to transform it into this slope intercept, and then I need to transform it into that standard form. I am given a slope, I'm given a point. So you know when you're given a point and a slope, praise the Lord, mathematicians are not creative. We tell you what to do. You're going to plug it into that point slope form. So here's point slope, And remember, the reason that there's no subscript here is to remind me that stays as a variable. This stays as a variable. I'm going to plug into here, here, and here. So what's going to go right here? Absolutely the y-coordinate of a -1. What's going to go right here? Absolutely that slope of 6/5. And what's going to go right here? Yep, that x-coordinate of 4. Now, is there any cleanup that needs to be done? You know that whole subtract and negative kind of stuff? Yeah, it's sitting right here. So I'm going to clean that up as y plus 1 equals 6/5 times x minus 4. And I'm not going to distribute because my point slope form keeps that parentheses in there. So ta-da, there it is, point slope form. Now what I'm going to do is take this equation, I'm going to transform it into this slope intercept form. And like we said before, that means get that y by itself and get rid of that parentheses. And we discussed before that it does not matter the order you do that, just get both things done. But like I said, many people struggle with, if they go ahead and slide the 1 over, they distribute too far. So I'm going to go ahead and distribute first, and when I do, I'm going to get a 6/5 x minus, okay, now everybody's freaking out with these fractions. You've got this. Stay strong. So I'm going to put this 4 over a 1, and remember, math gang, I'm going to cancel those diagonals, but look, nothing cancels here, nothing cancels here. I'm going to try to cancel up and down. Nothing cancels here, nothing cancels here. I'm ready to shoot straight across. So when I shoot across 6 times 4 is 24, and then 5 times 1 is 5. Now calm down. I know we got fractions. We're okay. We got this. So I'm still trying to get slope intercept form. The parentheses is gone. I need to slide the 1 over so that the y is by itself. How do I slide it over? Yes, I subtract it. So I'm going to subtract a 1 here, subtract a 1 here. When I do, that will give me y equals 6/5 x. Now, a negative 24 over 5 minus 1, common denominator, when you add and subtract fractions, you need a common denominator. It's going to be 5. So a 1 is a 5 over 5. And notice that the signs are the same. If you need to, when you're subtracting the 5 over 5, you can look at it as adding a negative 5 over 5. You have same signs. When you have same signs, you combine the digits and keep the sign. So I know I'm going to have a minus, and when I combine the digits, since I have common denominators, I can go ahead and add up those numerators. 24 and 5 is a 29 over 5. There it is. Believe it or not, that's my slope intercept form. I know, it's kind of scary looking with the fractions, but that's it. That's slope intercept form. Now my task is to translate it into standard form. So remember, standard form, 3 criteria. No fractions, no decimals, x and y together, constant on the other side, and the x coefficient needs to be positive. Any order you want, just get them all done. Most people can't stand the fractions. They want to get rid of them quick. So what's making these fractions is these denominators. I'm going to multiply absolutely everything by that 5 so I can get rid of it. And I mean every single term. So multiply this by 5 to give me a 5y. Multiply this by 5. But remember, bam, there's that gang symbol again. You can't get rid of it. I'm going to cancel these diagonals and get a 6x. And I'm going to cancel here as well. And I'm going to get a minus 29. Now, close. First of the 3 criteria done. Second criteria, get x and y together. So I'm going to slide this 6x over. When I do, I'm going to subtract it. So I have a negative 6x plus the 5y equal to, remember that name tag sign. In front's a sign that goes. You do not put that name tag on the back, because if you do, I'm not going to know who you are when you go to that meeting. When you go to the meeting, you put your name tag on the front so that I can identify your face with your name and I know who you are. Sign in front's a sign that goes. It's a name tag. This is a negative 29 here. All right, second criteria done. X and y together. Constant on the other side. Now I just need to make this positive. And like we said before, what that indicates is multiply everything by -1, divide by -1. It's all the same stuff. I'm just changing signs. So I'm going to change this sign. I'm going to change this sign. And I'm going to change this sign. Ta-da! There it is. I am in standard form. Done. Done and done. Now, I want to stress something to you. What you see circled in blue, what you see circled in red, and what you see circled in purple. Let me go to this, refer to this one. What you see circled in blue, what you see circled in red, what you see circled in purple, they all are the same line. A lot of people get that confused, and they think that these are three different lines. No, they all represent the very same line. It's just three different names for the same line. Kind of like my name is Lori James, but I could go by James, Lori, or maybe I could just go by Lori, or maybe I go by Mrs. James. But all three of those names represent the same person. They all represent me. And this is three different ways to write the name for the very same line. Same thing down here, what's circled in blue, what's circled in red, what's circled in purple. All three of these represent the very same line, just different ways to write the name of that line. All of these are the line that has that slope, tilts that way, and goes through that point. And the same thing up here. So that's very important that you understand that, because like I said, a lot of people think that these are three different lines, and they definitely are not. They are all the same line. Now, you know I like you to have a lot of examples to get you very comfortable with stuff, so yes, I've got more coming. Okay, so we got a couple more examples here, same directions. We want to write the equation of the line, transform it into that slope intercept, and then transform it into that standard form. So let's take these given conditions. I'm given a point and a slope. We keep saying mathematicians not creative people, so if you're given a point and a slope, you better put that thing in point slope form. So here's my point slope form. Y minus y1 equals m times x minus x1. I'm going to write it down every single time I use it so that I won't forget it and I'm going to memorize it without even trying. Now I took the subscript off of this one to remind me it stays as a variable, and I did the same thing here. So what will go here? Yes, that's going to be that -2. And what will go here? Yes, that's that slope of 0. And what will go here? Yes, that's going to be the x-coordinate of 3. My cleanup is that this subtracting a negative is really adding a positive. Now, let me point something out to you. Depending on who your teacher is, depending on what textbook you are using, publishing company or author that you're using, some people will say, yes, this is your point slope form. And they will say that's your point slope form because point slope keeps that parentheses right there. However, some teachers in some textbooks say, now wait a second. 0 times anything at all is just a 0. So I really have y plus 2 equals 0. And then some will say, you know what? It's not that hard to slide that 2 over. And when I do, I'm subtracting it off, and that will give me y equals -2. So, some will want you to stop here because, like I said, point slope retains that parentheses in there, and they say that's it. Others will want you to go on for a couple of reasons. One, they will say, no, wait, when I have to transform this into slope intercept form and get that y by itself, what's going to happen is I'm going to multiply by 0, giving me a 0, and then I'm going to subtract that 2, and then ta-da, right here, I'm going to get that slope intercept form because now the y is by itself, and they're going to say, you know what, if I go ahead and do this, then those who want to carry on, they say, well, if the ones who don't want to stop here at point slope, and they stop here with the parentheses in point slope, and they want to keep going because they're like, it's not that hard to do. So those who will keep going and they will call this point slope, the reason they do it is because they say, well, that's point slope and slope intercept all in the same shot. That's why some prefer not to stop here when you have a 0 for your slope. Because they're like, hey, how cool is it that point slope and slope intercept are the same? But if your teacher or your textbook says, no, I want that parentheses in there, then here's your point slope, here's your slope intercept. Because yes, the y is by itself. Now watch this awesomeness happen. I need to transform it into standard form. Remember those 3 criteria? Criteria 1, no fractions and decimals. Bam, don't have them. Second, put x and y together. Hey, I don't even have an x. Bam, done. And third one, I need my x to be positive. Well, I don't have an x. Bam, done. So not only is this slope intercept, this is standard form as well. And again, that's one of the reasons why some people don't want to stop here and call this point slope. They want to carry on to here and call this slope intercept standard form and point slope all in the same shot. Now, something interesting. Remember, in a previous video, we said we're going to read this as y has to be a -2. y has to be a negative 2. Well, here's y of negative 2. Here's y of negative 2. Here, 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 here. Remember, we don't care what x is because there's not an x there anyways. And when we connect all this, we have that horizontal line. Remember the skier who was sleeping on that horizontal line? The z's meant what type of slope? Yeah, the z's meant 0 slope. We have 0 slope here. So this makes sense that this would be the equation of that line, to have a 0 slope and go through this point. If it's a 0 slope, it's a horizontal line, and that horizontal line is going to cut through this y-axis right there at a negative 2. So the y has to be a negative 2. It all comes together. That's a beautiful thing when that happens. I always love it when that happens. To me, that's the cool thing about math. But anyways, so now let's take a look at this illustration here, this example that says I want the same directions. I want to write the equation of the line. I want to transform it into slope intercept. I want to transform it into standard form. But wait a minute, I don't have slope. Because remember, in all the previous examples, we were given a point and a slope. We don't have a slope. What are we going to do? Yeah, you've got this. You can get slope because you know your formula for slope. And that formula for slope said, let's subtract those y's on the numerator, let's subtract those x's on the denominator. And remember, it does not matter the order you subtract the y's, just make sure you go in the same order on those x's. So when I subtract the y's, let's do 4 minus 3. Now, if I go 4 minus 3, I have to do it in the same order with the x's, 2 minus 1. Now, 4 minus 3 is 1, 2 minus 1 is 1. I have a slope of 1. Now, I have a slope and, oh no, 2 points to choose from when I write that point-slope form. But I'm going to prove to you that it does not matter which form you choose. It really, truly makes no difference. So let's go with the first point. I'm going to plug it into my y minus y1 equals m times x minus x1. I'm going to choose this first point right here. When I plug it in, this will be 3 from the y-coordinate. My slope will be 1. And this, my x-coordinate, will be 1. Now, I can get rid of that 1 because I don't have to show whenever I've got a 1 sitting outside of parentheses, and this is going to be my point-slope form. However, if I choose this one, y minus y1 equals m times x minus, actually let me slide this over this way. Here we go, y minus y1 equals m times x minus x1. And if I choose the second point, the y-coordinate is going to be 4. My slope is still 1. And if I choose the second point, my x-coordinate is going to be 2. And once again, I don't need that 1 sitting there. So this is what I have. And this is my point slope. Now, here's the problem we have. Those of you who would have chosen the first point, here's your equation for point slope. Those of you who would have chosen the second point, here's your equation for point slope, and you're looking at each other's equations going, oh my gosh, we got a problem. So these guys are going, you're wrong, and these guys over here are going, no, 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 you're wrong. And there's a big fight ensuing because everybody thinks each other's wrong. This is the beauty of transforming it into that slope-intercept form. Watch what unfolds here. Remember, slope-intercept, y equals mx plus b. I need to get the y by itself. Here, the only thing I have to do is add that 3 to the other side, and I'm done. So I'm going to add that 3, and that will give me y equals x plus 2. There it is, slope-intercept. Here, to get that y by itself, all I have to do is add 4. And when I do, I get y equals x plus 2. Oh my goodness, check it out. They're the exact same thing. So see, it really doesn't matter which of the 2 points you choose. The beauty of this is when you translate into that slope-intercept, you will find out, oh my gosh, they really are the same equation. They're not really the same equation, I'm sorry, but they are the same line. Both of these represent the same line that is also represented by this equation as well for slope-intercept. So now that last part of the direction says put it in standard form, and you know 3 criteria. I need to get rid of fractions and decimals. They're not there anyways. I need to get the x and the y together. So all I have to do is slide that x over here. When I do, I get a negative x plus y equals 2. And then I just need to make sure that this x is positive. All I have to do is change all the signs. So I get x minus y equal to a negative 2. Ta-da! I have standard form. So, two things. One, if you have 2 points, you're good. All you gotta do is use your formula for slope to get slope. Two, it does not matter which of the 2 points you use, because you can see that they are going to get you to the same slope intercept form, which will get you to the same standard form. If you had to translate to general form, it would get you to the same general form. The whole idea is it doesn't matter which point you choose. Now, I've got many more examples for you, so just hang on. Now, this one's going to be a bit of a doozy, and that's why I really want to do another one. So I have got 2 points, same directions here. I need to write the equation of the line, then translate it into slope intercept form, then translate it into standard form. So we know, once again, if I'm given 2 points, I've got to get that slope. I mean, everything's got slope in it, except for the standard form, but everything's got slope. So let's start with that, and let's subtract those y's on that numerator. And let's subtract those x's in the denominator. And like I keep saying, it doesn't matter the order you do the y's, just make sure you do the same order on those x's. So I'm going to do 1 minus a negative 2, 1 minus a negative 2. So then I have to go 5 minus 3. And we know that subtracting a negative is really adding a positive. This is really a 1 plus 2, which is 3. And 5 minus 3 is a 2. There's my slope. Now, I just proved to you already that it doesn't matter which point you choose, but I want to prove it one more time with this one. Because this slope at 3/2, the previous example had a slope that was a whole number, it was a 1, and that was so easy to work with. But I want to show you, even with a fractional slope, it still doesn't matter which point you choose. So I'm going to start here with the first point, and I'm going to plug it into that point slope form. Because remember, when I've got a point and a slope, hey, mathematicians are not creative. We call it like we see it. You better use that point slope form. So remember, I took the subscript off of this one to remind me it stays as a variable. I took the subscript off of this one to remind me it stays as a variable. I'm going to use this point. So this 3 is the x-coordinate. The negative 2 is the y-coordinate. And my slope is this 3/2 that's right here. Now remember, with the point slope form, I need to clean up this kind of stuff here. Subtracting a negative is really adding a positive. But remember, with point slope form, I don't need to distribute through. So here is point slope. Now, like I said, it doesn't matter which point you use. So let's try this one out. So here I go, plugging it into my y minus y1 equals m times x minus x1. And when I plug it in, I get y minus 1 equals 3/2 is my slope times x minus 5. Is there any cleanup that needs to be done? No, there's no subtracting a negative or anything like that. So if I use the second point, here's point slope. And like I said before, those of you who use the first point, you're going to look at this and you're going to go, you guys are wrong. And you who use the second point, you're going to look at this one, you're going to go, you guys are wrong. There's going to be a big fight. This is the beauty, like I said, of transforming it into that slope intercept. So I need to get the y by itself and get rid of that parentheses, because there's no parentheses in here. So, like I've said many times, you can slide that 2 over and then distribute, but a lot of people make mistakes when they do that. So I'm going to distribute first, and when I do, I get 3/2 x. Don't have a heart attack with these fractions, it's okay. Put that over a 1. Multiplying fractions, we're going to cancel on the diagonals. But nothing cancels here, nothing cancels here. I'm going to check up and down. Nothing cancels here, nothing cancels here. So I'm ready to shoot straight across. So when I multiply 3 times 3, I get a 9. And on the denominator, 2 times 1 is 2. And a positive times a negative is a negative. I know it's a mess, but we're good. We've got this. So to get the y by itself, I need to subtract 2. And that will give me y equals 3/2 x. Now, the only thing is, here, when I do that negative 9/2 minus 2, I'm going to put the 2 over a 1, and I need a common denominator. Common denominator will be 2, so I have a negative 9/2 minus 4 over 2, because I'm going to multiply this by 2, multiply this by 2. And then, when I combine these, and again, this is like adding a negative, I've got the same sign, so that means combine the numbers, and since they're fractions, I'm going to keep the denominator of 2, and I'm going to combine the numerators. Negative 9 plus negative 4 is negative 13 over that common denominator of 2. And ta-da! You have got slope intercept form. I know it's ugly, I know it's got fractions in there, but that's slope intercept because you don't have a parentheses and the y is by itself. Slope intercept. Now, let's work this one. because you're going to find that this will come up to be the same as that. Remember, I can slide the 1 and then distribute, but I prefer to go ahead and distribute to keep me from making mistakes. So 3 half x, put that 5 over 1, and be in that gang one more time. So I'm going to check these diagonals, nothing happening, nothing happening. So I'm ready to shoot straight across because nothing cancels up and down here or here. And I get a negative 15 over 2. I'm not done. The y is not entirely by itself. I'm going to add 1, I'm going to add 1. And that will give me y equals 3 halves x. And then here, once again, I have to get common denominators. But a 1 is going to be a 2 over a 2. Now, these signs are different. So I take smaller digit from larger digit, take the 2 from the 15 to get a 13. Keep that denominator of 2, take the sign of the larger digit, which is negative. What do you notice here? Oh my gosh, they really are the same. It's a beautiful thing. Isn't that a work of art right there? I just think that's gorgeous. When I got things that feel different, they don't feel like they're the same thing, and they come together as the same thing. That is poetry. Anyways, so now my last task is to transform it into standard form. So I'm going to get rid of all my fractions. I'm going to get my x and my y together, and I'm going to make sure that that x is positive. Now, to clear out the fractions, what I'm going to do is I'm going to get rid of these denominators. That's what's making them fractions. So I'm going to multiply absolutely everything by 2. When I multiply the y by 2, I get a 2y. When I multiply this by 2, those diagonals are going to cancel, and the 2's will cancel completely. I'll get a 3x. And here, the 2's will cancel as well, and I get a negative 13. So, fractions are gone. Now, all I have to do is slide that 3x over. When I slide it, I'm going to subtract it. And that 2y is positive. Be very careful, name tag here, that's a negative 13. And the last thing I have to do is make sure that this front coefficient is positive. And in order to do that, I'm just going to change every one of the signs. Ta-da! There is my standard form. And like I said before, what's circled in blue, what's circled in red, what's circled in purple, they all represent the same equation. Just different ways of writing the same equation. They all mean the same, no, I'm sorry, not the same equation. They all represent the same line. Just different equations or different names for the very same line, but they all represent the line that goes through those 2 points. Okay, more examples because I really do want you to feel comfortable, and there's lots of crazy things that you can see, and I don't want anything to stump you. Okay, so here we go, a couple more examples. And I know like you feel like I'm just beating this down and there's so many examples, but really different nuances kind of throw people off, and I want to catch this stuff for you to make life easy. So once again, I know I need to get that slope because I've got slope intercept, I've got point slope, I got to get slope. So I'm going to subtract my y's on the numerator, x's on the denominator, and remember it doesn't matter the order you subtract the y's, just make sure you go in the same order for those x's. So I'm going to do a negative 4 minus a negative 2. Whoops, what am I doing? Ah, I don't know what happened there. There we go. And that means I have to go negative 1 minus a 0. Now, subtracting a negative is really adding a positive. Negative 4 plus 2 is a negative 2. Negative 2 over negative 1 is going to be a positive 2. There's my slope. Now, I have proven to you already with 2 examples that it really doesn't matter which point you choose. It makes no difference. But let's think about something here. I'm going to plug this into y minus y1 equals m times x minus x1. Now, when I plug that in, my m is going to be 2. Let's think about something here. I could either plug a negative 4 in here and get y plus 4, plug a negative 1 in here and get a x plus 1, or I could go with this one and plug that negative 2 in here and get a y plus 2 and plug this 0 in here and go, oh, x minus 0. You know what? Which one's going to be easier to work with? Yes, this one. Because there's a 0 in there, meaning this is just going to be an x instead of an x plus 1 and then having to do all this extra distribution and these extra steps. This is going to make life quick and easy. So I'm going to go with that. Because it doesn't matter the one you pick, so pick the one that's easy. And like we said before, we got to do a little bit of cleanup here because subtracting a negative is really adding a positive. So I'm going to get a y plus 2 equal to a 2 times x minus 0. Now, like I said, those instructors and textbooks who say, I want that parentheses in there, then they're going to say this is your point slope form. However, ones who say, now wait a minute, it's not that hard to say that this is just an x, and therefore it's not that hard to say that this is just a 2x, will say carry on further. But that's up to your instructor and your textbook. Now, my second part of this instruction said turn that into slope intercept. So if I'm going to turn it into slope intercept, I need to get the y by itself. Well, if I did this and just said, well, this is just an x and it's just a 2x, then all I have to do now is subtract the 2. Because I've already gotten rid of the parentheses. And ta-da, there I am sitting on slope intercept in a quick and easy step. And again, that's why a lot of people will want you to go ahead and just call this an x and make it a 2x. But that's up to your instructor and your textbook. Now, I need to turn this into standard form, 3 criteria. Get rid of fractions and decimals. Score, don't have any anyways. Second one, get x and y together. Okay, I'm going to slide the 2x over. And when I do, I'm going to subtract it. Keep those name tags. That's a -2, that's a positive y. But when I slide it across the equal sign, I need to change its sign. And now I just need to make sure the x is positive, which we now know means just change every one of those signs. And ta-da, this is my standard form. So like I said, whenever you can pick a 0, pick it, because that makes life super easy. With that in mind, take a look at this example. Same directions, so I know I'm going to have to get that slope first, which means I'm going to have to subtract those y's on the numerator and my x's on the denominator. And hey, this is looking pretty easy because I'm going to do a -1 minus 0, because that's just a -1. And then I'm going to do a 4 minus 0, because I did this one minus this one, so I'm going to do the same order on those x's, giving me a slope of -1/4. Now, here comes the cool stuff. Because remember, I said it doesn't matter the point you choose. So which one do you want to work with? Which one's going to make your life easy? Yeah, that one right there. Because I'm going to put a 0 here for this y. And then I'm going to put a 0 here for this x. Oh my gosh, life is so easy. Now here again, if your textbook, if your instructors say, nope, I want the parentheses, then you can call this point slope. This is where it gets a little sloppy as to what you're going to call point slope. Because this is just a y. And you know what? That's just an x. So back in my day, we would have called that point slope. Because it's not that hard to do. Plus, check it out, you're already in slope intercept. You already have the y by itself. You already have all the parentheses gone. So yeah, back in my day, we would have gone ahead and cleaned that up and cleaned that up. But pay close attention to what your textbook and your instructors say. Now, my last thing is I need to turn it into standard form. 3 criteria. I'm going to get rid of my fractions. I'm going to multiply everything by that 4 that's in the denominator, whatever's making it a fraction. That'll give me a 4y equal to a -x, because the 4's will cancel, but the negative will not cancel. And now I'm going to put my x and my y together. So I'm going to slide the x over. I'm going to add it to the other side. The 4y is positive. Now here's what trips people up. When I add the x over here, notice that there's nothing left on that side. Nothing left. So what's over here? Yes, a 0. And notice that when I slid that x over, now that made it positive. So in one step I took care of 2 things. And we now have standard form. Okay, I just have a couple more examples. Last couple of them, because these are strange. They really do throw people off, and I want you to see this so nothing messes you up. All right, last examples here. I've got the same directions. I need to write the equation of the line. I need to transform it into slope intercept, and then I need to transform it into standard form. So we know we have to start with getting that slope. So I'm going to subtract those y's on the numerator, x's on the denominator. Doesn't matter the order I subtract those y's, and well, how about that? They're the same thing anyway, so it really doesn't matter. So I'll go 4 minus 3, because I know 4 minus 3 is 1, but more importantly, I know up here that subtracting a negative is really adding a positive, and I'm going to come up with a 0 up there. And we've discussed before that when 0 is in the numerator, remember what that indicates is the numerator tells me how many objects I have to pass out. The denominator tells me how many people are out there to receive it. So I don't have any markers in my hand to pass out. There's one person. You are out there to receive it. How many markers do you get? Right, you don't get any. So when 0 is in the numerator, my answer is 0. There's my slope. Now, I'm going to take this and I'm going to put it into my point-slope form because remember, if I need to write the equation, I've got a point and a slope. That's what I'm going to use as point-slope. And I've already proven to you that it does not matter the point that you choose. So I'll just go with this first one right here. So I'm going to keep this as a variable. That's why I took the subscript off. And that means I'm going to put the -3 right here where the y is. My slope of 0 is going to go right here. And my x is going to be 4. Now my cleanup is that subtracting a negative is really adding a positive. And we've got this. And we discussed before that with that 0 out front, well, it can stay out front if your instructor in your textbook wants you to leave the parentheses in there and call this point slope. Or you can take that a step further because you know this entire side is just a 0. In which case you've got y plus 3 equals 0. And it's not that hard to subtract that 3 off and get y equals -3. Which, ta-da, I got my slope intercept form right there. So if your teacher, your instructor in your textbook say, no, you don't have to stop here and you can keep going, then you can call this point slope and slope intercept in the same shot. It's dependent on your instructor in your textbook. But now I need to translate it into standard form, those 3 criteria. Well, guess what? I don't have fractions and decimals anyways. Check. Now, my x and my y, oh, I don't even have an x. So let's just say they're together because I don't have an x. Check. And if I don't have an x, can I say it's positive? Oh yeah, I can. So all 3 things are done. And the beautiful thing is not only is this standard form, or sorry, slope intercept, it is standard form as well. Wonderful thing. Okay, last example here. So I'm going to get my slope. I'm going to subtract my y's on the numerator, x's on the denominator. And now when I subtract my y's, I'll do a 2 minus a -3. So I have to go in the same order on the x's. Oh, check it out. X's are the same. So I get a 0 in the denominator, in which case it kind of really doesn't matter what I did up there on that numerator. Now here I'm going to get a 5. If I would have done the other order, I would have gotten a -5. Doesn't matter. Because when 0 is in the denominator, what does that mean? Remember, the numerator here says I've got 5 markers to pass out, but the denominator says there's nobody out there to get them. So I'm trying to pass the markers out. I'm really giving it my best, but I cannot make the action happen because there is nobody out there to receive them. So therefore, when 0 is in the denominator, my slope is considered to be undefined. Now, I am ready to write the equation of the line in that point slope form because I've got a slope and I've got 2 points to choose from. And so now when I go to do this, and I'm just going to choose my first point right here. So that means, remember, I took the subscript off of this one so it'll stay as a variable. The 2 will go right here. I took the subscript off of this one so that it'll stay as a variable. The 5 will go right here. And what goes here? Oh, yeah. Okay, that's weird. That's really weird. I mean, how do I put undefined right there? Well, that makes no sense at all. How am I going to do this? Because I can't really distribute. That's not a 0. It's not a 0. It's undefined. So now how do I distribute that through the parentheses? What on earth am I going to do? Now, those of you with sharp eyes, I want you to take a look right here at what you've got. What do you notice about these 2 points that you see right here? Do you see anything special here? Yes, there it is. Notice that both of them have x coordinates that are 5. So in other words, the x has to be 5. The y value can change, but the x, I need to guarantee that it's a 5. So how do you write x has to be 5? Yes, x has to be 5. And that is the only equation to represent that line. That's the only one. So this is your point slope, your slope intercept, and your standard form all in one shot. There is no other equation to represent that. And let's think about why. Notice that if I was to graph this, well, 5, 2, 1, 2, 3, 4, 5, 1, 2, 5, 2 sits here. 5, negative 3 sits here. Now, what type of line do I have right there? Yes, that is a vertical line. What do you know about the slope of vertical lines? Think that skier. Remember, you've got puff, puff, positive. You've got nice, negative. Here, what was the skier doing? Taking a nap. The Z's meant 0. And on that cliff, falling off and going to be undefined in the end. I know that's horrible, but undefined in the end. So your vertical lines had undefined slope, exactly how we saw it. And remember, on this vertical line, every one of these x coordinates are a 5. Y can be anything. Y can be a 2, it could be a negative 3, it could be a 0, it could be a negative 1, it could be fractions and decimals. But the x had better be a 5. X cannot be anything but a 5. So this is the only equation that can represent that line. It's the only equation that represents the line that goes through those 2 points. Now with that in mind, think about this one. If I go to graph these, 1, 2, 3, 1, 2, 3, here's 3, negative 3, and then here's 4, well, let me clean this up a little bit, that's a little difficult to see. Here we go. Here is 3, negative 3, here's 4, negative 3. What type of line is that? Yes, that's horizontal. And remember I just said with the skier, we had puff, puff, positive, nice, negative. On that horizontal line, what was the skier doing? Taking a nap, and the Z's meant, yep, 0 slope. It's all coming together. And on this horizontal line, notice that these x coordinates are changing up. This one's a 4, this one's a 3. This one back here is a negative 1, that one's a 0. We got fractions and decimals. But what is absolutely true? Yep, those y coordinates have got to be a negative 3. How do you write y has to be a negative 3? Right there. So that's why, like I said, some instructors, some textbooks say, I don't even want to fool with this. I'm just going to call it a y equals negative 3. Because that is the line that represents that, or that's the equation that represents that horizontal line. And this is the equation that represents that vertical line. But it depends on your instructor. It depends on your textbook. What none of them do is none of them accept this as your point slope, because you just can't put a word in there. It makes no sense. You can't do that. So, those of you who think outside the box, those of you with very keen eyes, you won't even have to go through all this. You'll notice right off the bat, oh, they both have the same x-coordinate. And if they both have the same x-coordinate, then ta-da, x has got to be 5. And this is how you write x has to be 5. And again, those of you with the keen eyes who think outside the box, you're not going to have to go through all of this stuff either. Right here, you're going to go, oh, check it out. Both of them have the same y-coordinate. How do I write y has to be a negative 3? Right here. Y has to be a negative 3. Saving you a lot of time and a lot of headache. Now, those of us like me who don't have the keen eyes, don't think outside the box, no, I wouldn't catch it and I'd go through all this, but I'm still getting there. And same thing here. I wouldn't catch it. I'm going to go down here and I'm going to get undefined and I'm going to try to put it in there. I'm going to go, what on earth? But then I'm going to look at it and then I'm going to catch it. So if you don't catch it right off the bat, it's okay. You'll get there. But this is how it goes. So hopefully this helps you with this idea of the point slope form, the equation of a line. Man, it is a super, super helpful form. Not everybody teaches it. Not everybody uses it. Some people really don't like it. They prefer just to go with that slope intercept. But this is so helpful. When you're given a point and a slope, you just throw them in there. And then all you got to do is distribute and slide that y-coordinate over and you're in slope intercept. And more importantly, when you see this, you can pull the point out, you can pull the slope out, you can graph those and make your line. So I hope that helps. Have a great day.